Right now, your phone knows exactly where you are. Inside, outside, it doesn't matter. It knows which floor you're on. It knows which direction you're walking. And it never asked. For thousands of years, people got lost. Sailors stared at stars, held compasses, prayed. Sometimes they still drifted off course. Now, a rectangle in your pocket finds you with less than 3 meters of error. Every second. Free. Silent. So how is that even possible? The answer is in space. Right now, 31 satellites are orbiting Earth. Let that land for a second. 31. Right now. Always. Up there. And every single one is broadcasting a signal. That signal travels at the speed of light, 300,000 kilometers per second. It passes through the atmosphere, through your building, through your pocket. It reaches your phone. Your phone measures exactly how long that took. And from that time alone, just that tiny window of time, it calculates how far away the satellite is. It does this millions of times a day, without you ever noticing. But knowing the distance to one satellite isn't enough, because distance only puts you on the surface of a sphere. You could still be anywhere on that sphere. Millions of possible locations. A second satellite narrows it down. 2 spheres intersect. You're now somewhere on a circle. Third satellite? Now just 2 points remain. Fourth satellite? 1 point. You. This is called trilateration. 4 years of high school geometry solved by your phone in 1/1,000,000th of a second. And the clocks doing this calculation, the clocks inside those satellites, lose 1 second every 300 million years. 1 second every 300 million years. But here's the problem. Actually, several problems. The signal bends as it passes through the atmosphere. Rain, clouds, humidity, they all slow it down slightly. In cities, buildings reflect the signal. Your phone receives both the real signal and the echo, and it can't always tell which is which. But the biggest problem comes from Einstein. Time in space runs differently. Because satellites move faster than us, their time ticks slightly slower. But because they're farther from Earth's gravity, their time ticks slightly faster. These two effects don't cancel out perfectly. The result is a drift of 38 microseconds per day. Sounds tiny? Left uncorrected, GPS would be off by 10 kilometers every single day. So how is it still this accurate? Because engineers solved every single problem in advance. The relativistic drift is baked into the satellite software. Ground stations send daily clock corrections to every satellite. Your phone listens to multiple satellites simultaneously and averages the results. The outcome? Standard GPS is accurate to under 3 meters. Professional grade systems reach 2 centimeters. 2 centimeters. Think about that. 31 satellites orbiting 20,000 kilometers above you, each one moving at 14,000 kilometers per hour, each one firing signals at the speed of light. And together, this system finds you with the precision of a snowflake landing on a specific tile. GPS started as a US military project. It launched in 1973. Opened to the public in 2000. Free. For everyone. Now, the entire world depends on it. Planes, ships, trucks, banks. Every transaction is GPS timestamped. Power grids synchronize using GPS signals. Emergency services navigate by GPS. If GPS went offline tomorrow, economists estimate global losses of $1 billion per day. $1 billion. Per day. Just because the satellites stopped talking. And underneath all of it, 31 small boxes, silently circling the Earth. Solar panels catching sunlight. Atomic clocks ticking without rest. Answering a question humans have asked for as long as we've been alive. Where am I?
So here's the full picture. Satellite sends a signal. Your phone measures how long it took to arrive. 4 satellites do this simultaneously. Geometry finds the intersection. Relativity gets corrected. A blue dot appears on your screen. That's it. But the next time you open Maps and that blue dot snaps into place instantly, remember that in that exact moment, 4 satellites, 20,000 kilometers above you, traveling at 14,000 kilometers per hour, are comparing their atomic clocks to your phone, just so you can find the nearest coffee shop. The invisible is everywhere. You just have to know where to look.